Hello everyone and welcome back. Today we are discussing a new transformation. Today we're discussing reflections. Previously we've discussed translations in which we slide a figure across a coordinate plane, up, down, left, or right. All right, and today we're moving on to a reflection. I'm pretty sure we will be pretty comfortable with reflections as it's something that we see in everyday life. It's something we practice, maybe even without even realizing we are practicing it. So, to start us off, a reflection is a type of rigid motion in which each point in the pre-image, remember that's the image that we start with, is the same distance from the line of reflection. As its corresponding point in the image. Okay, so basically all this means is we're going to have some point or line of reflection. And if something is reflected over that line, then it's going to be the same distance away from that line of reflection. All right, so I'm going to shrink this just a bit. Okay, well then a line of reflection, okay, could be the x-axis, the y-axis, or honestly, any other line. Today we are focusing mainly on x-axis, y-axis, and something like the equation y equals x, but we'll get to that, okay? So this first guy, it asks us to reflect the pre-image across the x-axis and label the image A prime, B prime, C prime, D prime. Okay, so first off, we've got to identify the x-axis. That is my horizontal axis on my graph, so I'm going to go ahead and highlight this guy. So we know that is what we're reflecting across. Okay, now, here's my skill or strategy. You are welcome to use it. You are welcome to maybe just visualize it a lot easier. So by all means, if you can see it and you know exactly where to go, perfect. If not, let's do it this way. So I'm going to start with A, and I'm going to count how far away A is from that x-axis. I count 1, 2, 3, 4, 5. Okay? So what that tells me is I'm then going to go in the opposite direction. So from the x-axis to A, I go up 5. To get to A prime, I'm going to go down 5 from the x-axis. There's A prime. Okay? I'm going to do the same for B. I count from the x-axis 1, 2, 3, 4, 5, 6. So I'm going to count 6 in the opposite direction. 1, 2, 3, 4, 5, 6. There's B prime. And C is just 1 away from the x-axis, so I'm going to go 1 away in the opposite direction. There's C prime. Now, here's where I'll pick a different color just so we can see it. All right, D is actually below the x-axis, and it's 1 below the x-axis. So I'm going to go 1 above the x-axis instead. So always thinking opposite directions. So A, B, and C were all above the x-axis, therefore we went below the x-axis to get our new image. But D started below the x-axis, so it's going to end above. And there is my new image. Cool. So now we're going to reflect A prime, B prime, C prime, D prime, that orange one we just drew, across the line x equals 1 to create a new image. So x equals 1. I have a little trick for us. There's a trick called HOY, HOY, VUX, VUX. And what this tells us is if I just have a just have a line of x equals something. X equals 2, x equals -2, x equals 0. In our case, x equals 1. That gives me a very big clue that my line's going to be vertical. And it's going to be vertical at the point 1 on the x-axis. So, use this. It will be so helpful, I promise. When it's x equals something, we have a vertical line at x equals 1. X equals 1. If it's y equals something, we have a horizontal line at that y equals value. Okay? And let's use a different color. Let's go purple. Okay, so now I'm looking at these points A prime, D prime, C prime, and B prime, okay? And we are looking at how far away it is from that new line that we just drew, x equals 1. So, once again, I have to count how far away A prime is. It's 1, 2, 3, 4, 5, 6, 7, 8 away from that new line. So I'm going to count 8 away in the other direction. 1, 2, 3, 4, 5, 6, 7, 8. There's a double prime. I'm going to do the same for B. It's 1, 2, 3, 4 away. Then I'm going to go 1, 2, 3, 4 away in the other direction. There's B double prime. C, it looks like 1, 2, 3 away. We count 1, 2, 3 to get C prime. C double prime. Here, D prime is 1, 2, 3, 4 away from x equals 1, so we're going to go 4 away in the opposite direction to get D double prime. All right, we'll go through, connect these dots, our new vertices, to get our new reflected image. Okay? Now, let's see if we can maybe come up with an overall rule, I guess, when we have these points and we're reflecting them. Okay, so just because I think shapes help us see the reflection, I'm going to fill these guys in. I'm going to connect and make my triangle. Okay, now let's list the points for Q. The coordinate points. So Q is here. I'm going to see that that is -5 on the x and -4 on the y. I'm going to do the same thing for R, which is -3 on the x, 2 on the y, and lastly W is 1 on the x and 3 on the y. All right, so please, if we struggle with writing those x, y values, always just maybe draw a line down to the x-axis. What point does that hit? Well, it hits at 1, so that's going to be my x value. And then do it with the y. It hits at 3, that's going to be my y value. Okay? So, we have to reflect across the y-axis. So, remember, x is the horizontal, y is the vertical. So we are going across this axis to start. I'll start with Q, and I count that Q is 1, 2, 3, 4, 5 away from the y-axis. So I'm going to count 1, 2, 3, 4, 5. All right. I count that R is 1, 2, 3 away. So I'm going to count 1, 2, 3 away for R prime. And then W is on the other side of the y-axis to start, so it is 1 away. So we're going to go 1 away in the opposite direction to get W prime. We'll draw our new triangle, beautifully reflected over the y-axis. Let's fill in those new prime x and y values. So now Q is at positive 5, negative 4. R is at positive 3, 2. And W prime is at negative 1, 3. Do we notice anything that happened here between these 2 points? Or I mean 2 sets of points? Should be fairly noticeable. Focus on maybe the x values. Well, there's actually a rule that tells me when I reflect over the x-axis, all right, all that happens is my original x value becomes negative, and my original y value stays the same. Okay? So, let's take a look. Oh, I got rid of my 5. Let's take a look just to make sure. Negative 5 becomes positive 5. Well, a double negative would be positive, so that works out. Negative 3 becomes positive 3. Good, checks out. And positive 1 becomes negative 1. Yeah, all those x's turned negative, while all the y's stayed exactly the same. Huh. Interesting. Something to hold on to. Okay, let's keep moving.